We are going to be doing yet another example where we migrate the first-person character. Again, all stuff that you have already covered in previous modules. We are just essentially doing a recap with a real-world example. So here we've already started migrating the first-person character, but we're going to finish off the job and get everything that's in this event graph over into C++. Now, the sticking points that I foresee are going to be getting hold of the grabber, because that means that we would have to bring over everything here that we have currently got in the first-person character, including the camera and the grabber as a sub-object, and everything there is all going to have to go over in C++, unless we expose this as a Blueprint implementable event. So that's what we're going to do. I'm going to go over into the header file, and we're going to create a protected function. I'll do this under begin play, which is going to be a U function that is a Blueprint implementable event, and it is going to be Blueprint pure. And then what we want it to return is the uGrabber, which is a class that we already have. So let's make sure we include it. Again, includes just above the generator.h. I can't stress that enough. Hash include is going to be to the grabber.h. So that then we can include the type there, uGrabber asterisk, and we're going to call it getGrabber, funnily enough, and it is going to be const. So we don't need to create an implementation over in C++. Let's just compile and make sure we have that implementation in Blueprint. So let's go over to the Blueprint first-person character. Let's dock that tab. It looks like it wasn't docked. So then in functions, I'm going to hit the override drop-down and look for our getGrabber function. And this is where I'm going to just return the reference to the grabber component that we have instantiated here on our first-person character. So now we can get hold of that grabber in our C++. So let's go over to the C++ and have a look at how we're going to hook up this functionality. So first of all, our forward implementation. This should be fairly straightforward. So let's go over to the event graph and have a look at what we have disconnected here. So first of all, we're getting the forward vector of the actor. That is pretty much going to be the same. Get forward vector, get actor forward vector is the function on the current actor. Then we were multiplying it by the axis value. That should again be fairly straightforward. Asterisk axis value. Then we are getting the character movement component, which is actually still available here. Character movement. All we have to do is call the function getCharacterMovement, and then we need to have the correct include, which is going to be up at the top. We're going to hash include the game framework / and it's going to be the character movement component. So that allows us to call methods on the character movement component, and what we want is the add input vector. So that's what we're going to call add input vector, like so. And the thing that we're going to add is the multiplication of the forward vector with the axis value, and that should give us what we need in here. Now I'm just going to go and fast forward through the process of doing the almost exact same thing, but with the right vector for the axis right. And as you can see, that was pretty much a copy and paste and replacing forward with right in a few places. So let's build that and see whether we can move around. Go over to Blueprint and delete all the stuff at the top that is about the forward and the right axes. Compile, save, hit play, and see if we can move around. Yeah, we can move forward and we can move left and right. So we have successfully moved those across. Next, let's have a look at lookup and lookWrite. Now, in this case, we don't actually have to create a function because there is already a function in one of the parent classes, the add controller pitch input and the add controller yaw input. So we're just going to go ahead and bind those directly. It's just going to be a bind axis call, player input component, bind axis, and we're going to do the text macro for, as we said over here, it's the lookup is the first one. Calling it on this particular instance, and then we're going to do the ampersand a pawn because that is the class it is on. If you go and have a look over in Blueprint, you can see that the target is pawn, and then we're going to do : the add controller, and in this case it is the add controller pitch input, which should hook up just fine like that. And then we are going to go ahead and do the lookWrite. And this one is adding the controller yaw input instead. Now, if you wanted to do anything fancy, of course, you would put some function in between that we implement here locally. But seeing as we don't need to do anything fancy, this should be fine. Let's go ahead and build and see the result. So after we have built, we can go and delete our lookup and look right events in Blueprints, and we can go over to the main map, hit play, and check that the mouse is able to have us look around, which it is. So the next thing in our sights is the jump function, which again is a function in a parent class. In this case, it's the character parent class. So we can go ahead and instead of calling to this jump, we're going to call to a character. And in this case, it's actually still called jump. And what we want to do is remove the private jump function that we've got on the first person character because that is bogus and we don't need it. Now let's go ahead and build and see what the result actually looks like. Again, we're going to be deleting this jump extra extraneous stuff in the blueprint. Go and hit play, hit the spacebar and see that we're able to jump. So the final target in our sights is this grabber grab and release. Now we're going to have to create a function for grab and release both locally because it will not work if you try and bind to something that isn't this, that is something dynamic in here. So we're going to go ahead and create another bind action. So I'm just going to copy this line and we're going to do text. The name of the action is grab, and we're going to create two of these. One of these is going to be for the input pressed. Again, its target is this, and then the function we haven't yet created. And then the second one is going to be released instead. Let's go over to the header file to create these. We're going to have a void taking no arguments grab function, and we're going to have a void release, again taking no arguments. Go back to the C++. In fact, we want to implement both of those, so let's copy their signatures. So let's create their definitions, and then we go over to our C++ again, and we're going to go ahead and bind those. So ampersand grab, and then we're going to do the same ampersand release and get our semicolons and our indentation fixed, and we should have the bindings that we need. The only thing that remains is for us to actually call that function on the grabber. So we're going to have to call to get grabber in here, arrow, and then we want to call the grab function on the get grabber. Not forgetting my parentheses there. Now we haven't actually implemented grab or release over in the grabber, but it is relatively straightforward to do, seeing as we've already brought across most of the functions. So let's go ahead and do it super speedily. We're going to have a U function that is going to be blueprint callable over here at the top, and it is going to be a void grab function. And then we're going to repeat it having U function blueprint callable, which is going to be a void release instead. And we're going to go ahead and implement both of these over in the C++. Then let's go over into the C++ body and see what the result is and what we're going to actually implement. Now I'm just going to go through this really quickly, but you can compare this result against the blueprint to make yourself sure that we're doing the right thing. So first of all, we're going to have a variable to store the hit actor as an out parameter, and we're going to also have a U primitive component that we store the hit component into. We're then going to do a trace, so it's going to be trace for physics bodies. Hit actor is going to be one out parameter, and then the hit component is going to be the other. Then in the body of the if, so if we do hit anything, we're going to call on the hit components. What are we going to call? We are going to call the set simulate physics, and we're going to set that to true as a first port call. Then we are going to get the physics component of this grabber, and we're going to tell it to grab the component at location with rotation. And what are we going to tell it to grab? We're going to tell it to grab the hit component. We're going to give it name none because this is for the bone that we want to attach to. We've got no bones here because we're static meshes. Then we're going to do the hit component, and we're going to get the center of mass, which is where we should grab it. This is really just translating the blueprint after all. And then we're going to set a kind of null rotation with passing in an empty construction of an F rotator. And then semicolon at the end of that line. We're going to then notify the quest actor with the hit actor that was hit by our grabber. The implementation of release is far simpler. We're just going to do the get physics component, and then we're going to release that component. So now we should be able to go back to the first person character CPP and call those grab and release functions. So again, I'm going to do the release is going to be fairly straightforward, get grabber, and then we call a release on that. Let's build and see what the result is. We can see that we now need to delete the grab and release functions in the grabber blueprint, and everything in the first person character compiles just fine, and we can go and test it out in the scene. So I'm going to do that by right-clicking in the center of the village and doing a play from here, then going up to the pumpkins and trying our press. Yep, we've got a pumpkin, so the grabbing mechanism is working, and then a release. And all of that is going via a binding in C++, and then the grab function that we've implemented in C++ as well. That's been the result of this module. Hopefully you've been able to follow along. It's been rather a whistle-stop tour, but that should have helped you to solidify a bunch of knowledge about moving things over into C++.